question number 30, I've put in the Newton's quotient, x plus h to the power 3 over 2 minus x to the power 3 over 2 over h. So this is our Newton quotient. Now to do this a little bit easier, what we're going to do is we're going to write it in its square root form. So we're going to end up with square root of x plus h cubed minus the square root of x cubed. And the reason why we're doing this is because we need to free up that h in the numerator, and to do that we need to get rid of the square roots, the binomial square roots. And we can get rid of binomial square roots by multiplying by their conjugates. So I'm going to get the conjugate here, x square root plus the square root of x cubed, and do the same on the bottom. Okay, now by doing that, I'm going to end up getting a difference of squares, which allows me to get rid of the square roots. So I end up with the limit as h approaches 0 of x plus h cubed minus x cubed. Okay, square root squared minus square root squared. So the square roots disappear, and I have my h factor, and I have this expression in the denominator, but since we don't have to worry about this dividing by 0, we're just going to evaluate this when we can. So this is x plus h cubed. Okay, so I need to then free up this h in here. I can do that by using a binomial expansion, and that will allow us to cancel out some terms. So I end up with limit as h approaches 0, I end up with x cubed plus 3x squared h plus 3x h squared. So I'm using the binomial theorem, plus h cubed, and then minus the x cubed that is right there. In the denominator I have my factor of h. Okay, notice that when the x cubes cancel, I'm going to be able to cancel out my h factor, and I have my x plus h cubed plus square root of x cubed. So the x minus the x cubes cancel out. Okay, so I end up with the limit as h approaches 0 of 3x squared h plus 3x h squared plus h cubed all over h, and the rest of the denominator here. So I'm going to cancel out my h's. I've got one h here, that becomes h squared, and now I've got rid of that divide by h. So that's the key. So now I'm going to rewrite this again without the h's, and I can see that now at this point I can evaluate this limit. So I get 3x squared plus 3xh plus h squared all over the denominator, x plus h cubed plus x square root of x cubed. When I substitute in 0, that becomes, I end up with 0 terms here, 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 and then, so what's left over is 3x squared over square root x cubed plus square root x cubed, or 2 square root x cubed. Okay, and then if you want, you can simplify that to 3 over 2, and then this becomes, this is the cube of x to the power 3 over 2 in the denominator, so it becomes x to the 1/2 in the numerator. Okay, so this becomes 3 root x over 2.